Number 11, discuss the concavity of the function f of x equals x squared minus 4 squared. To find the concavity, we need to get to the second derivative. To get to the first derivative, I'm going to actually, since this is parentheses, I'm going to call this u squared. So f prime will equal 2u times the derivative of the u, which will be 2x. And so that, my derivative will be 4x times u. Okay, before taking the second derivative, I could make the choice to use the product rule or distribute. I'm going to make the choice to distribute to 4x cubed minus, 16x. Okay, and then from here, to get the second derivative, it will be 12x squared minus 16. I'm then going to find the critical number by setting it equal to 0. Adding 16 to both sides, I'll get 12x squared equals 16. Dividing both sides by 12, I will get 4/3. And then to get rid of the square, I take the square root of both sides. So I'll get x equals, notice it's going to be plus or minus the square root of 4/3. And I'm actually going to rewrite that as plus or minus 2 over the square root of 3. Either of those answers would be acceptable, however. Okay, doing an f double prime chart now. We'll put negative 2 over the square root of 3 on our chart and 2 over the square root of 3. Testing something to the left, for sure negative 10 would be less than that number. And so if I go into my second derivative and plug in negative 10, I'll get 1200 minus 16, which is a positive number. In the middle, I'll test 0. If I plug in 0, I'll get a negative number. And if I test 10 over on the right side, I will get a positive number once again. So if I'm discussing the concavity, I now can say that f is concave up on the interval negative infinity to negative 2 over the square root of 3, and then also again from 2 over the square root of 3 to infinity. And the reason this is concave up is because f double prime is positive. Okay, and then I will discuss that f is concave down on the interval negative 2 over square root of 3 to 2 over square root of 3, and that is because f double prime is negative. Problem 12, find the x-coordinate, if any, of each point of inflection of the function. Points of inflection, we would test the second derivative. So the first derivative of this function would be 4 cosine x plus 2x. The second derivative will be negative 4 sine x plus 2. And then from here, to get a critical number, we will set that second derivative equal to 0. Subtracting 2 from both sides, I'll have negative 4 sine x equals negative 2. Dividing both sides by negative 4, I'll get sine x equals 1/2. So if I'm looking for where does the y value on the unit circle equal 1/2, that would occur at pi over 6. And that's not the only place. If I'm looking at the unit circle, pi over 6 would be right here. The sign is also positive over in the second quadrant, which is a little bit before pi, so that other value would be 5/6 pi. So those are the two numbers I'm going to put on my f double prime chart, pi over 6 and 5/6 pi. On the left side, I'm going to test 0, and if I go into my second derivative, the sign of 0 is 0, so 0 plus 2 would give me a positive value. In between these two, I'm going to pick pi over 2, which is up here. The sign or the y value up here would be 1, so I'm going to end up getting negative 4 plus 2, which is a negative number. And then if I test 2 pi over on the other side, it's going to be the same thing as if I tested 2 pi, so that's also going to be positive. So if I'm looking for points of inflection occur when f double prime changes sign. So there are two places. So there are points of inflection at x equals pi over 6 and at x equals 5/6 pi. And that is because f double prime changes sign. Problem 13, discuss the concavity of the function f of x equals negative 5x squared. Again, to test concavity, we're going to go to the second derivative. The first derivative would be negative 10x. The second derivative will be negative 10. Notice that derivative can never equal 0, so when I go to do my f prime chart, there's no critical number to put on it. And negative 10 is always going to be a negative number, so the second derivative will always be negative. So if I need to discuss the concavity, since f double prime will always be negative, f will be concave down all the time. So to describe all the time, that will just be from negative infinity to positive infinity. And the reasoning is because f double prime is negative. Okay, problem 14. Find the x-coordinate, if any, of each point of inflection of the function f of x equals 1 over x minus 3 squared. Again, if we're getting 2 points of inflection, I need to get to the second derivative. Before I do that, you could use the quotient rule, but I'm going to take the easy way out here. I'm going to just move the x minus 3 up top and make it a negative 2 power. And then also from here, I do notice I have parentheses, so I'm going to turn that into u to the negative 2. So when I take the derivative, I'm going to get negative 2 u to the negative 3 times the derivative of what's inside. The derivative of what's inside is just 1. Okay, and so that just gives me negative 2 u to the negative 3. And then I need to take the derivative one more time. So I'm going to bump my negative 3 out front. That would give me positive 6 u to the negative 4, again times the derivative of what's inside, which again is just 1. So my second derivative is going to be 6 over u to the 4th. And rewriting it with the u in it, my second derivative will equal 6 over x minus 3 to the 4th. Okay, when I'm getting my critical numbers, now I will look at where would the numerator equal 0? 6 will never equal 0. Where will the denominator equal 0? The denominator will equal 0 when x equals 3. So my critical number will be x equals 3. So taking the second derivative, my critical number is 3. To the left of that, if I put 0 in here, when I raise it to a 4th power, that will become a positive value. And then if I plug 4 in there, I also will get a positive answer. So I notice that there are no points of inflection because f double prime never changes sign. So I am going to put no points of inflection because f double prime does not change sign.